Students, in the last video, we ended with the mass of an atom. So, let us continue with chemical symbols of elements. Now, you students have studied about this and you students have some idea regarding the chemical symbols of the elements, and you know the symbols of elements also, isn't it? Now see, how is an element indicated in chemistry? So how is an element indicated in chemistry? You know, you write some symbols, you denote it with some symbols, isn't it? And atomic number and atomic mass number also is indicated in those symbols. So this was taught to you in standard 9th. Yes. Now see, in the typical periodic table, each element is listed by its element symbol and atomic number. For example, for hydrogen, H is denoted, for lithium, Li is denoted, and so on. Most elements are represented by the first letter or first two letters, right? For carbon, you know, C. For helium, it is He. So, usually it is denoted by the first that is first alphabet or first two alphabet, that is the first two letters of their English name. But of course there are some exceptions for this also. For example, sodium is represented by Na, mercury is represented by Hg, gold Au, silver Ag, right? Yes. Now see, this is the actual way for denoting the element. You can see this, actually this is the symbol of the atom, that is if it is carbon C, if it is nitrogen it is N. Now mass number of nucleon, okay, so here the mass number is indicated, A means mass number, and here the atomic number is given. Write down the symbols of the elements you know. Yes, so you're going to write this, okay. You'll in the if you take out the modern periodic table, you will get the symbols of the elements. So write down some of the symbols of the elements, you should know this. Then write down the symbols for the following elements, that is antimony, okay. Antimony is Sb, iron it is Fe, gold Au, silver Ag, mercury Hg, lead Pb, sodium is Na, isn't it? So this also you'll find it in the periodic table. Now this is very important, you should know this, the symbols which are denoting the elements. Now Dalton used certain signs represents elements, okay. So for example, you can see this is for hydrogen, okay, this is for copper. Today we use the symbols determined by IUPAC, International Union of Pure and Applied Chemistry, okay. So before, okay, yes, during the time of Dalton such signs were used, but now such signs are not used. We are using the symbols which are determined by this IUPAC, that is the International Union of Pure and Applied Chemistry. Now these are official names and symbols and are used all over the world, okay. So these names which are there, which are declared by this IUPAC, that is the International Union of Pure and Applied Chemistry. So the symbols which are determined by this, okay, that is going to be the official names and the symbols, okay, and this is used all over the world. The current method of choosing chemical symbols is based on the method invented by Berzelius. So the current method means the method which we are using now, Okay, so this method was invented by Berzelius. So this scientist invented, and we are using the method which was invented by this Berzelius. According to this method, the symbol of an element is either the first letter or the first and second another specific letter in its name. Of the two letters, the first is a capital letter and the second is small, isn't it? Now, for example, hydrogen, I told you. Yes, see, I'll show it to you. Hydrogen, okay, is denoted by H, right? Yes, now this is the first letter of hydrogen. Now if you take helium, okay, it is denoted by first and the second letter, that is He. Now the first letter, okay, is going to be capital and the second letter is going to be small. Now, molecules of elements and compounds. Atoms of some elements such as helium, neon have independent existence. It means that these elements are in a monoatomic molecular state. Sometimes two or more atoms of an element combine to form molecules of that element. Such elements are in a polyatomic molecular state. For example, the elements of oxygen, nitrogen are in a diatomic molecular state as O2, N2 respectively. When atoms of different elements combine with each other, the molecules of compounds are formed. In other words, compounds are formed by chemical attraction between different elements. Now see the molecules of elements and compounds. Now what happens is some of the elements like helium, neon, okay, these elements, okay, they can exist independently. They need not combine with any other element or even with themselves, okay, in independent state, that is in monoatomic molecular state, they can exist. Mono means what? Single. In a single atom they can exist in nature. Now but sometimes, okay, instead of monoatomic state, two or more atoms of an element will combine. Now for example, see, helium and neon, okay, yes, see, helium, neon, they can exist in the, that is in independent state, okay, yes, that is monoatomic state. But some atoms, okay, they cannot exist in monoatomic state, they are found in the combined form. So like oxygen, okay, two oxygen molecules will combine and they exist in diatomic state, they cannot exist in monoatomic state. Nitrogen also in a diatomic state, they can exist in nature. But atoms of different elements, okay, for example, water you take, see, water if you take, you know, hydrogen, okay, and oxygen, two elements, that is two different elements, they are going to combine with each other to form a molecule of a compound, right? This is a compound. So compounds are formed by chemical attraction between different elements. Okay, now make a list of elements in the monoatomic and in the diatomic molecular state. Okay, so you're going to make a list of the elements which can exist in monoatomic state and the list of elements which are going to exist in diatomic state, just like how hydrogen, that is I told you, oxygen, okay, yes, they are going to exist in diatomic state, and you know the that is this helium, neon, krypton, all this are going to exist in monoatomic state. So you're going to make a list of such elements. Now, molecular mass and the concept of mole. Molecular mass. So let us study the molecular mass first, okay, and then the concept of mole. Now, the molecular mass of a substance is the sum of the atomic masses of all the atoms in a single molecule of that substance. So what is this molecular mass? It is the sum of the atomic mass of all the atoms. See, below in the table you can see. See, water is given to you, okay? The hydrogen H2O, formula is H2O, isn't it? Now, hydrogen is 1. So, you know, this mass is 1. But how many molecules are there? 2 molecules are there. So, 2 into 1, right? So, it is 2. Now, oxygen is, the atomic mass of oxygen is 16. Now, how many molecules are there in water? 1 is there, right? So, 16 ones are 16. So, mass of oxygen is going to be 16 in water. So, when you add this 2, okay, 16 plus 2, it is going to be 18. So, the molecular mass of water, that is the atomic mass of hydrogen and the atomic mass of oxygen. See, the atomic mass of water is atomic mass of hydrogen and atomic mass of oxygen. Hydrogen, you know, it is 2 atoms, right? Yes, and oxygen, it is 1. So, that is atomic mass of hydrogen. 1 into how many molecules? 2 molecules of hydrogen. So 2 into 1 plus atomic mass of oxygen is how much? 16. Molecules how many? 1. So 16 ones are 16. So it is going to be 2 plus 16, that is 18. So once again let me tell you, see, the molecular mass of a substance is the sum of the atomic masses of all the atoms in a single molecule of that substance. Now I think you will understand this by seeing this table, isn't it? Now see, use your brain power. Following are atomic masses of a few elements in Dalton's and the molecular formulae of some compounds. Deduce the molecular masses of those compounds. Now see, atomic mass is given to you here. Very easy. I'll show you. See, atomic mass of all the elements is given to you here, isn't it? See, that is hydrogen is 1, oxygen is 16, nitrogen 14, carbon 12, potassium 39, then sodium 32, sulfur 32, calcium 40, sodium 23, chlorine 35.5, magnesium 24 and aluminium 27. Now sodium chloride, see 1 or 2, I will show it to you. So that you will be able to find the molecular mass of other compounds, right? So let me show you the first one, sodium chloride. See, N A C L, okay. So see, sodium, you can see above it is 23, only one atom of sodium, plus chlorine is 35.5. So you're going to add these two. Okay. So it is going to be 35.5 plus 23 is how much? 58.5. Right? Yes. So 58.5 is the molecular mass of sodium chloride. Now magnesium chloride, if you take, okay, magnesium is 24. See, magnesium is 24 and chlorine is 35.5 again. Yes, so magnesium formula MgCl2. Okay, so magnesium is 24. How many atoms? 1 plus chlorine is 35.5 into, so atoms how many? Chlorine 2, right? Yes, so it is 24 ones are 24 plus 35.5 into 2 is how much? 71, right? So if you add this 24 plus 71, it is going to be, see, 95. So the molecular mass of magnesium chloride is how much? 95, right? Yes. Now potassium nitrate, okay, yes, KNO3. Now from here you are going to try this. Potassium is given to you 39. See, I'll just give you an idea. Okay, potassium is how much? 39. Okay, nitrogen is how much? N. See, it's given to you over here 14. How many atoms? Only one atom of nitrogen. So only that is 39 plus 14 plus oxygen is how much? 16. But how many atoms? 3 atoms of oxygen. So it's going to be 16 into 3. So 39 plus 14 plus 16 into 3. So when you add up all, you are going to get the molecular mass of potassium nitrate. So in this way, you are going to find out the molecular mass of the remaining compounds. I'm sure you must have understood this. See, let us see the small video clip regarding the chemical symbols.
We're going to learn about chemical symbols. So what are chemical symbols and how do they work? Well, it says right here that a chemical symbol is the code for a chemical element. And most of the time they are derived from the name of the element. However, in some instances, they are derived from the Greek or Latin name of that element. So let's take a look at a few examples of some chemical symbols here. And hopefully you catch on. It says right here, if the chemical symbol of an element has only one letter, then that letter is going to be capitalized. For example, the chemical symbol of potassium is K. It only has one letter in it, so we're going to go ahead and capitalize that letter. The chemical symbol for tungsten is W. So because it only has one letter, we're going to go ahead and capitalize that W. And last but not least, the chemical symbol for carbon is just C. And because it only has one letter, then we're going to go ahead and capitalize that letter. Okay, if the chemical symbol of an element has two letters, then the first one is always going to be capitalized and the second one will always be lowercase. For example, chlorine, we have capital C, lowercase l, bromine, capital B, lowercase r, and sodium right here, capital N, lowercase a. Now you might be wondering, why is the chemical symbol for sodium Na? Well, that has to do with the Greek or Latin word for that element, and that's what we're going to take a look at next. We're going to look at some of the chemical symbols for elements that are derived from the Greek or Latin words. Let's take a look. All right, let's take a look at a few weird ones here. We have iron. The chemical symbol for iron is Fe. You might be thinking it should be Ir, but it's capital F, lowercase e. Why? Because in Greek or Latin, the word for iron is going to be ferrum. And so you can see.
For iron, it is Fe, isn't it? Yes, but it's not denoted by IR. I told you that is the first letter or first and second alphabet is denoted. But here in case of iron, it should have been IR, but it's not like that. Why? Because Latin word is ferrum. Okay. Yes, and that is why, see, it is Fe.
Where we get Fe from. Silver, Ag, you would think would be maybe Si, but it's not. Why? Because the chemical symbol here is derived from the Greek or Latin word for silver, argentum. Same with sodium, right? Sodium you think might be So. However, the Greek or Latin word for sodium is natrum. That's where we get Na from. Potassium is simply K because the Greek or Latin word for that is going to be kalium. And
So I'm sure you have understood this, right? Now see, let us continue with mole in the next video.